Mr. Rishabh Verma is the CEO and co-founder of UrbanMatrix Technologies Pvt Limited. He has a passion for technology and an urge to bring innovation to the market. He started his journey by building drones at the Center of Innovation. And during his first year of college at UrbanMatrix Technologies with other young startup, he handles business development, marketing and client relations, financing and compliances in HR management, and many more things. Under his leadership, with his other co-founders, UrbanMatrix Technologies has developed highly advanced drone technologies, which is providing solutions to the problems previously left unaddressed by other drone companies in India. Off to you, Mr. Rishabh Verma, to present to us the 4G in drones.
Thank you so much, Sandra. Hello, everyone. I hope everyone is having a great weekend and learning a lot about what's going on with the drone industry. Uh, so, a brief introduction about UrbanMatrix. Uh, we started UrbanMatrix back in 2019 in a city called Chennai in South India. And since then, we have been experimenting with a lot of technologies around it. We are basically building drones, building softwares for these drones, building electronics. And in that journey, whatever we have learned, I would love to share that today. So please let me know if my screen is visible, the presentation screen is
Is
visible or not.
Yes, it's visible.
Rishabh, we can see the PowerPoint, not the slideshow. You want to put it in the slideshow?
Okay. So this is the slideshow right now. Is it visible now?
No, you need to probably switch. Maybe first put it in the slideshow and then start sharing the screen.
Okay. I'll try that as well.
Perfect.
Yes. Can you see the different slides right now?
Yes, we can.
yeah.
Perfect. Yeah. So the idea behind building 4G technology with these drones. Let's start with that. So what is the concept of 4G in drones? Now, whatever machine which we are developing, whatever robot which you are developing has to be controlled. Currently, there are a couple of methods by which you can control a drone. The first method is radio communication, which is the most popular method as well. Almost 99% drones today are being controlled by radio communication. Now, this radio communication requires you to have a direct line of sight connection between your remote controller and the drone, and that is the biggest challenge. So the connectivity with the radio controller is usually, good for 1 kilometer, 2 kilometers, and beyond that, you will start facing difficulties, especially in smaller drones. Now, to overcome this problem of connectivity, you can either put up more expensive, more power hungry electronic system on the drone and increase the range of the drone, or you can look for another options for communicating with the drone. One of these other options would be 4G or LTE technology. Today we are seeing that companies like Geo and Reliance and Airtel are bidding for 5G as well, so that is also coming in future. And talking about LTE connectivity, it doesn't require your line of sight communication. So this essentially means that you can actually send data directly to your nearest mobile tower and then to satellite, and then from satellite to your ground station servers. So controlling a drone now becomes independent of the ground controller station or the remote controller, so to say. So the traditional way by which we are controlling every drone with a single pair of a controller sort of transforms into a controlling system which is centralized. So that is how 4G in drones is defined very briefly. And talking about how it works a little bit technically is that your drone is sending the data using the 4G communication to a server. Now, this server can be hosted locally the server can be hosted on international platforms like AWS or Microsoft Azure, or you have a secure server which is independent of any other third party like AWS or Microsoft. Once you have this data in the server, that is then sent to the command center. That is the endpoint. And once you have the data at the command center, you can take decisions right from the command centers. Uh, so, what are the benefits of having this kind of communication platform? First of all, you can do a live control for the drone, its payload, sitting from your command center, sitting from your offices, sitting from your headquarters. For example, you are sitting in Delhi and you're controlling a drone which is flying in Bangalore, or even its payload which is there. So that is about live control. Second is artificial intelligence. Now, artificial intelligence is helping drones in multiple ways in all the sectors: agriculture, delivery, obstacle avoidance, surveillance, and security, and such. To truly experience a end-to-end solution where you have a live feed from the drone and you have intelligence layer based on the artificial intelligence algorithms, and then final data is coming to your computer, coming to your screens, you definitely need a very powerful processor. Now the problem with that powerful processor is uh, it takes a lot of space, it takes a lot of weight, it takes a lot of energy, and that's why it is very difficult to put a very powerful computing system on the drone. So the best method to solve this problem is that you stream the data from the drone directly to the servers where they can handle any kind of computational power required at the server level. And that's where 4G comes in. So when you have a 4G network coverage area, then the data which you are sending in forms of photos, in forms of videos, is actually can be transformed into a much more powerful and intelligent data set using these artificial intelligence algorithms, which are running on the server, not on the drone. Then we also have APIs and OTA opportunities where for example, you have your drone which needs an update in terms of its software, which needs an update in terms of a new sensor integration. Now, in those sort of situation where you have to update these softwares, usually you have to, get this drone back to your manufacturer, and then they will open it up, put up the new software. But with the 4G technology, that is not required. You have your Android phones and iOS phones where you have these software updates now and then, right? Similarly, in the drones also, you can have these kind of OTA updates, over the air updates. So your drone doesn't require to be sent off again back to the manufacturer for these kind of updates. And again, with the APIs, you can provide powerful data sets to or utilize these powerful data sets like videos and drone health or number of flights, pilot data, any sort of data uh, into your existing workflow. For example, you have a dashboard which is already integrating multiple CCTV footages. Now you want to also integrate drone footages or drone videos in the same dashboard, in the same ecosystem. Then with the 4G networks, we provide APIs in such a form that you can actually plug and play those video streams into your existing systems. Again, talking about fleet management, again, it's a very, very huge challenge. And in future, it has to be solved, and there is no other way to scale up, this drone in any sort of applications. So to tackle fleet management, the basic idea is that you can, track a drone when it's flying, where it's flying. And once you have the basic data like its height, its speed, where it's going, its flight path, and flight plan, then you can actually manage multiple drones as well. And that's where the concept of fleet management, arises. With the 4G ecosystem, multiple drones are sending these data back to the servers, and at the server level, you can have that fleet management. We have already done this and tried and tested this, which I will show you in the next slide. So yeah, these are two small pictures of the live 4G drones, how they are being used. In the left hand side, you are seeing that two people sitting in their offices are controlling a drone which is flying somewhere else. They can not only control the drone, they can make it land, they can take off the drone, they can control the sensor, they can zoom in, zoom out, and that all is happening without the need of the ground controller. You don't need the ground controller anymore. On the right hand side, what picture you are seeing is one of the police departments in India. So they are so this is their command center, and they usually have these kind of command centers where they have a lot of CCTV data coming in. It is very important for them to take live decisions. And in surveillance overall, we have these kind of situations where we have to take immediate decisions. For those kind of applications, again, when you have 4G infrastructure in place, the drone is directly sending these videos uh, to the server, and then you can actually see these live videos and take a action call based on that. um, this is again a few more examples how you can add on intelligence layer on top of the data. You can count number of peoples, detect, using facial algorithms, vehicle algorithms, cars, models, number plates, and such. The interesting part is that, especially to UrbanMatrix, we have been developing a lot of algorithms to reduce the latency, which is inherently there. So whenever you are sending the data from the drone to a server, it will take some time. Whenever you are processing that data with some intelligence layer or artificial intelligence algorithm, it will again add up on to some sort of time and delay. Uh, so when we started this development of this technology, the delay and sort of latency was around 40-45 seconds. And now 40-45 second latency and delay is a very large number when you have to control the drone from a remote location using this technology, or you have to take live decisions. Today we have that latency reduced to less than 1 second. Both intelligence layer and live video, both combined less than 1 second. So yeah, technology is becoming more and more matured and advanced and refined. Now, all the operations in future, when we talk about delivery, when we talk about spraying chemicals or pesticides or insecticides, when we talk about large scale operations, uh, it is not possible to scale up this technology when you have one remote and one drone. And when you have 100 drones, you will need 100 remotes, 100 pilots. That is not the way to scale up this technology. We need a centralized system where you have 100 drones and one control center. You have 200 drones, we have one control center. And that's where you require a technology which eliminates the ground control station remote controller system. And that's what we call GCS, less autonomous missions. To reach that autonomy level, we can leverage 4G technology and then control everything about the drone operations from the control room. So that's how we see the future of this technology growing. Now, what we have done in a very briefly, if I have to tell, this is basically a small computer which we have developed in the last 2 years of research. So this is Matrix CC. Today we have all our drones installed with Matrix CC, and this computer is the brain behind achieving all of these complex tasks. This computer comes with a 4G module. You can put a SIM card in that, and currently we are shipping it throughout India, and you can install it in any drone. And then once you have this in your drone, you have all the powers of 4G in your drones, which we discussed in the previous slides. This also comes with UMT console, which is the web-based cloud platform to manage all that. So yeah, it is a brief presentation. I hope I understand that we are already running late, but I'll be very happy to answer any questions regarding this. Thank you so much. Uh, that's all from my side.